It's ESP32 time, and we've got in here a room 32D, and it's a raw chip, but it's nestled in this program which I have featured in a mailbag before. It makes it so easy to program these guys. You just push it in there and then connect this up to your computer, and away you go, no dramas. And what I've done is I've just got it to be blinking an LED here, and that's the start of the project, but it is programmable over the air. So what I want to do is actually transfer this to this adapter, make sure that my original blinky is working okay, and then change the blinking code, but also add one of these relays. And I think in a previous video, I think on maybe a mailbag, when these came in, I pointed out that that extra hole there must have been put there by the work experience kid. But I should have read the side here. It says relay. And this actually fits pretty snugly in there. That extra pin, that's what it's there for. So I'm going to try to have this soldered up nicely, talking to the LED as it is now, and then reprogram it to maybe change the frequency or whatever for the LED, but also to get the relay going. Let's get soldering. Yeah, that's a pretty noisy fan just next to the workstation here, but it's better than huffing solder fumes. What we can do is use Audacity to filter out the sounds. Let's do that. All right, and let's get on with soldering this guy. I'm not sure how long this will take and whether I might not end up speeding up and putting on some Slack music or something, but the first thing to do is to tack one corner. All right, let's do a close-up inspection and kill those bridges I can already see. Good one. So success in the end. This is the female headers that I've just put around the adapter board. There's the ESP32 in the middle. There's a couple, well, there's three capacitors, a couple of 100 nanofarad and a 10 microfarad capacitor in there. There's a 10k resistor as well, so I'll put the schematic up for that. It's sort of almost like the minimum amount that you need to run the ESP32. There's a couple of other things that you could put on there so you could program it, but in all honesty, this one has already got an OTA sketch on it, so I can program it over the air. I've just got this blinking in a fairly unique blinking pattern, and what I'll do is over the air I will see if I can change this to something like a solid 2 seconds on and 2 seconds off. Let's give that a try. Ready to go with changing the speed of the blink over the air. So it's compiling and it's sending an invitation. I notice the blinking has stopped, so it says it's uploading. All good signs. I'm just waiting to see if that blinking has changed to 2 seconds on and 2 seconds off. Yeah, that looks good. Okay, that's pretty good. All right, so the next thing to do is to get the relay soldered in and see if we can't get some relay action happening there as well. Good result. Before soldering a few more components on this this test bed, if you like, for the ESP32 over the air device, I just wanted to make sure that I could communicate successfully with this relay that I've soldered in. Now this is a 5-volt relay, but it's 3.3 volts coming out of the GPIO here. And so I thought, well, I better mock up something, just make sure I can understand what's going on and get all the connections right before I commit to soldering this in. As it turns out, when I was looking for a 5-volt relay to match this one, I did find some 3-volt relays. So there you go. But this is 5-volt that's soldered in, so let's continue with 5 volts. Now into the system here on this rail here, I've got 7 volts coming in. That then goes to an HT7833, which I think we've seen on the on this channel and on the blog before. So that just gives me a nice steady 3.3 volts coming down to this side here. And I've got a common ground between the two. So when I switch it on, what I should find is that 3.3 volts is provided And I've just got an LED here to indicate that that side is actually live and working. And I have tested it, and it is 3.3 volts, so that's fine. Now, to simulate a high signal coming out of the ESP32, I've just got these two leads here. As soon as I connect these up, then there's a circuit complete here with the little 1K resistor you can just see hiding there. So it's a 1K resistor going to the base of my transistor. That's the logic level shifter there. So the transistor is an SS8050. So on pin 1, we've got ground, and or emitter, if you like, and then on the middle pin, that's where the successfully hiding, there it is, the 1K resistor goes to, so that's your base in the middle, and then there's your collector. So on the high side of that, we've got our 7 volts coming into our relay. We've also got COM is also 7 volts, and then draining out to the collector of the logic level shifter, the NPN BJT transistor. So the load at this stage, I'm going to just be using a high wattage LED, and I've got a fairly low, I think this is 3 ohm resistor here, or 3.3 ohm resistor actually I think it is, and I think this is a 3 watt globe on this side. So that should all be working. So if I just connect these two up, then you can see that that's working fine, and that's providing around about I think I've got the current limiting on my power supply set at about 800 milliamps. So yeah, not bad. So that seems to be working fine. Underneath here is, let's pull it out and have a look. I've had to put some legs, some extra legs on this thing here, so you can see here to make it a bit more breadboard friendly. But even so, it's sort of a little bit skew if as I was poking it in there. But underneath here, there's a 1N4148 diode, which is your flyback diode, so that if you happen to have an inductive load here, which I think I will, I think I've got a little motor here I'd like to try with this whole setup. So if you happen to get a bit of a kickback, even from the relay itself, which has got a coil in it, then to protect the electronics downstream, this little fairly fast switching diode is pretty necessary, and you'll see a lot of circuits with relays have this. I was interested to see actually, in case the relay points do become a little bit sticky, you can also put in series with this Zener diode set at pretty similar rating to the actual voltage itself. So eventually I'd like to try that, particularly for high voltage switching. But anyway, now that I can see that that is this breadboard working correctly for this particular relay, then I will put these components on here. That'll enable me to put pretty much any voltage up to the rating of this voltage converter here. So maybe I'll actually switch this out for a higher one, but I'd like to get in maybe 8, 10, even 12 volts coming in, but supplying 3.3 to the ESP32, and then via the same setup as we've got here, higher voltage to the relay, and have it switching quite fine and being programmable over the air. So that's the next stage of this little project. What we've got here is ESP32, which is programmed over the air, and it's able to, well, pretty much do anything out of the GPIO. So I've just got a slow blink here for an LED, and I've got it hooked up via a MOSFET. This is a BS170 to a relay, which is flicking on a large load. So 9 volts coming on that side, 5 volts coming on this side, and there's a regulator to drop it down to 3.3, and everything's going pretty well. Let's have a look a little bit closer. So the board that I've got here, I've just soldered up here a ESP32D, and it's not too bad, this board, except for one weird thing, and that is that the last pin here, which is ground, is not broken out. So there's only ground on this side and ground on this side. It's not such a big deal. But when you supply 5 volts to this one, I've just got a green light indicating that it is powered, and then over here I've just got a switch and a red light to actually switch the ESP32 on. As soon as it's connected, it goes into whatever program that you've put on there. In this case, just blinking of a slow LED here and a fast relay here. And it's also waiting for instructions over the air. I've turned the bright light off, but I can put that back on. And what I'd like to do now is to change this from a slow blinking LED to a fast blinking LED and a slow blinking relay. Sorry, a fast blinking relay to a slow blinking relay. Let's try that. Right, so we've got our sketch ready to go. I've just changed the LED delay to 600 milliseconds and the relay delay to 1500 milliseconds, or sorry, 1.5 seconds. It probably makes a bit more sense. So it's compiling it. It'll take a little while. I'll probably speed this bit up. And then the ESP32 is already connected to the computer via Wi-Fi. So just to help with the uploading, I've just popped on a 1000 microfarad capacitor because it does draw a little bit when it's actually trying to connect. So let's try this again, and we'll go to compile and upload. Might as well put on the big light as well. So then it's drawn from a different source. It shouldn't matter too much. And now it's uploading. So we're looking for a faster LED and a slower relay. Uploading still, looking good. Bit of a process. Still good. And it says it's done uploading. So let's see what the result is. And there you go. Faster LED and slower relay. Pretty good result, this one, and a bit of a playground here because there's lots of free slots. So you could put anything on there. In this case, I'm interested in switching a large load, but you could also do, you could break out all of these to things like buzzers and yeah, all sorts of different things, potentiometers, whatever you wanted. That is the circuit working for this week. Yeah, I like that one. That's nice. See you next time.